All right, let's jump right in. We're going to tackle one of the biggest puzzles in business today. How do you take a simple question, one asked in plain English, and turn it into a powerful, secure, and genuinely trustworthy piece of business intelligence? In this explainer, we're going to break down a blueprint for doing exactly that.
It really all starts with a question that pretty much every single business leader is asking right now. They want instant answers, and they want them to be right. So, on one side, you've got the dream, right? Just asking your system, hey, show me our top 5 customers by revenue, and bam, you get an immediate correct answer. But then, there's the messy reality. A tangled web of static dashboards, data scattered across a dozen different silos, and entire teams of analysts having to manually pull queries. This gap, this is where the promise of AI analytics is supposed to live, but it's also where most projects completely fall apart.
And that stumbling block is a really big one. It's led to what I like to call the AI pilot graveyard. It's this place where all these promising analytics projects end up when they just can't make the leap from a cool demo to a real production-ready system. So the question is, why? Why do so many of them fail? Well, it really just boils down to 4 huge risks. First up, unsafe SQL. This is where an AI agent could accidentally delete data or maybe run a monster query that just hogs all your resources. Then there's the problem of no audit trail. I mean, if the AI did something, who asked it to? What data did it touch? Without a log, you've got a compliance nightmare on your hands. Third, and this is a big one, hallucinations. The AI just straight up invents relationships that don't exist, giving you answers that are confidently and completely wrong. And finally, zero governance. With no limits, you get runaway API costs and a totally exhausted system.
So how in the world do you build a system that avoids all these traps? The answer isn't to give the AI more freedom. It's actually the opposite. It's to build a smarter, much more constrained system. And what we're looking at here is a blueprint for exactly that, a system built from the ground up on trust.
And this quote, this gets to the absolute core of the idea. It's a fundamental shift in thinking. Instead of asking an AI to guess how to write a complex SQL query from scratch, which is super risky, you give it a very limited set of pre-approved, well-defined tools it's allowed to use. This moves you from unpredictable guesswork to predictable, deterministic, and safe execution. And here's what that looks like in practice. A user makes a natural language request, right? But instead of that request going straight to the database, which is scary, it passes through this secure middle layer, this governed tool execution engine. Think of this engine as the ultimate gatekeeper. It contains all the rules, all the logging, and all the pre-approved tools to make sure every single request is safe and sound before it ever gets near your data. This entire blueprint for trust is built on what we're going to call the 3 pillars of safety. So let's break them down one by one, because this is how we go from a risky pilot project to a production-grade reality.
Let's kick things off with the first big problem, AI guesswork. When you just tell an AI to write SQL for something vague like revenue, it has to guess which tables to join, which fields to use, and honestly, it's an incredibly error-prone guessing game. The solution? We get rid of the guesswork entirely.
And that brings us to pillar number 1, using semantic tools instead of raw SQL. So instead of guessing, the AI is given a very specific tool, let's call it Top Customers by Revenue. That tool contains pre-written, human-vetted, deterministic logic. The joins are controlled, the KPIs are consistent, and there is zero ambiguity. The AI's only job is to pick the right tool from the toolbox, not to invent the logic itself.
Okay, so we've controlled the logic. That's a huge step. But what about controlling the access itself? The problem here is giving an AI agent direct, unfettered access to the database. That's kind of like giving a brand new intern the master admin password. Just no. The solution is to build a robust defense-in-depth strategy, which leads us straight to pillar 2. A secure SQL execution function acts as this non-negotiable gatekeeper. It has one job: filter everything. As you can see, dangerous commands like delete, drop, or update, they get blocked right at the wall. Only select statements can pass through, and even then, they're subject to strict row limits and privilege controls. This stops both accidental data corruption and those runaway queries that could bring your entire system to its knees.
All right, finally, we have to talk about the real-world operational stuff. What happens when this system is being used by hundreds, maybe thousands of people? Without guardrails, you're facing runaway costs from unlimited API calls and, of course, a total lack of an audit trail. The only real solution has to be built-in governance.
And that is our third and final pillar. Over on the left, you see rate limiting. By setting per-user thresholds, say 30 calls a minute, you can prevent abuse and those crazy runaway loops. And on the right, execution logging. Every single interaction, what tool was called, what SQL was run, whether it succeeded or failed, and exactly how long it took, all of it gets recorded in an audit log. This gives you complete observability and, crucially, accountability.
So there we have it, our 3 pillars: semantic tools, defense in depth, and built-in governance. Now let's actually see how they all work together in the life of a single, everyday query.
Okay, let's trace the path. Step 1, a user asks, show top 5 customers by order count. Step 2, the AI layer evaluates this and selects the one correct, pre-approved tool for the job. Step 3, that tool's governed logic is executed securely inside the database. Step 4, the entire transaction, start to finish, is recorded in the audit log. And finally, Step 5, a clean, simple JSON response is sent back to the user. See, it's a clean, safe, and fully auditable 5-step process, every time.
And what's so powerful here is that we can now directly map our solutions back to those initial pilot-killing problems. Remember them? Uncontrolled SQL? That's solved with our database guardrails. No audit trail? Solved with autonomous logging. Those dangerous AI hallucinations? Solved because we're using deterministic semantic tools. And no governance? Solved with database-level rate limiting. This architecture just systematically dismantles each and every point of failure.
Now, this whole process taught some really critical lessons. So here are 4 huge takeaways if you're even thinking about building something like this. First, your logging has to be autonomous. It needs to save everything, even if the main query fails. Second, security isn't just an app layer problem. It has to live deep inside the database. Third, for a system like this, using native database JSON types is absolutely key for compatibility. And maybe most importantly, you have to design your governance and your guardrails from day one. Do not try to bolt them on as an afterthought. It just doesn't work.
By swapping out that risky guesswork for solid governance, we can build natural language systems that are not just powerful, but also secure, compliant, and truly ready for the enterprise. So the final question is, with a blueprint like this, are you ready to finally move your AI analytics from a risky experiment to a real production-grade asset?